Hello and welcome to Algebra Unit 3-1 Lesson 7. Today's objective is scholars will develop and evaluate linear and exponential functions and work to find and make sense of the intersection of these two functions. So just a couple of questions for you to think about before we get started. What do you remember about solving systems of linear equations? You can see an example up here of a system of linear equations. Think about that for a minute. When we graph equations, what does the line or the curve, what does that line or curve represent? What does that line or curve represent? And finally, what does the intersection of the two lines tell us about those two lines? I want you to think about that as we move through this lesson. You're going to be putting your answers down on your classwork as we go through. Okay, so let's look at this situation. A large pond contains 300 guppies and 160 frogs. Suppose the guppy population increases by 25 guppies each year. Suppose the frog population increases by 25% per year. What does the future hold for this pond? Make a prediction. Please pause the video and make a prediction for what you think is going to happen in this pond. Okay, so hopefully you've made a prediction. Make sure your prediction includes information about what's happening with the frogs, with the guppies, and with the pond. Okay, make sure you correct your prediction and go ahead and unpause or you keep going. Okay, so the next questions I want you to think about. What factors might impact the growth of the guppy and frog populations? What types of factors might impact the growth? I want you to think about things like food, predators. Think about things like that. See if you can add more to that list. The next question asks us to use the words now and next to write a rule for how the guppy population changes each year. So remember, the guppy population increased by 25 guppies each year. So how about this for our words? Now we have 300 guppies. Next, we have 25 more guppies. This is why I'm looking for these now and next statements. Now we have 300 guppies. Next, we have 25 more guppies. Okay, so now we're going to look at this function G is representing the guppy population at year T. So remember, we're going to complete this table. So at year 0, there were how many guppies? 300. And then we're going to complete this by increasing it by 25 each time. So then we have 325, then we'll be at 350, and so on. So let's look at the next part. How does the guppy population change every 2 years? You should be able to answer that question without any guidance. How does it change every 2 years? Look at your table if you need help. Okay, next part, we are going to be asked to graph the data, T and G. Remember, T was the years and G was the guppy population on the set of axes. Then connect our data points. So at 0, we had 300. At 2, we had 350. At 4, we had 400. And you can see where this is going. We're going to connect these with a line. Okay, so you should do that on your graph. So next we're asked to write a formula to model the population growth. So remember, we're going to use y equals mx plus b. M is our rate of change. And b is our beginning, our starting point. So what is our function going to be? Please write a function using the rate of change at our starting point. And then use your formula to predict the population at year T equals 10. You should be able to do this without my assistance. If you need help, come see me. Okay, so now, the initial population of 160 frogs grows by 25% each year. Suppose the rectangle below represents a population of 160 frogs. So if this is 160 frogs, how much is in each of these? We see each of these is 1/4. So I know each of these is 40. Each of these is 40 frogs. On the grid below, the total rectangle represents the population after the first 25% growth. So you see these ones here that are 10 each because we got 4. Again, we keep writing 10 in each of these. And each one of these is one of those. Again, 10, 10, 10, 10. And then we have another 10, 10, 10, 10. And then that's our original part. And then we have this part is our growth. We grew by 10, 10, 10, 10. So what is the population of frogs at year T1? How many total frogs do I have here? Well, we can see I have 200. I have my original 160, and then I added 40 more. So on the grid below, we're going to model the model represents, the grid below, the model represents the population after 1 year. So remember, each of these now is going to be 50 because we have 200, right? So if each of these is 50, each of those is going to be a 10. This is our population after 1 year. What are we going to do? We're going to add another set of 50 to get the population after 2 years. Does the population increase by the same number of frogs each year? So think about how you went from year 0 to year 1, and then year 1 to year 2. And does it increase by the same number of frogs each year? The same number of frogs. Okay. So now we're using the same thing we are writing now and next statements to write a rule for showing how the frog population changes each year. So now I have, next I have. Now I have, at the beginning I had how many frogs? 160 frogs. Next, I have 25% more. Okay? Interpret the median of the population at year T3 in terms of the context of the situation. So you're going to figure out what the population is in the year T3 and then explain what it is in the context of the situation. And then we're going to write a function f representing the frog population at year T. So this should be an exponential function. So we are going to write an exponential function for our frogs. Please make sure it's something like this. F of t equals, what was our beginning? 160. What is our rate of change? We're increasing by 25%, so we are going to increase by 1.25 to the t. Okay, make sure that your equation is like that. Okay, so let's again. Use the table feature in your calculator. So if you go to the Desmos calculator, you can do a table and validate your formula. Draw the graph of the frog population on the set of axes that you already have. In what year does the population of frogs overtake the population of guppies? Remember, our guppies started at 300. Our frogs started at 160. Then I want you to list any limitations on these models. Are there any actual limits on these models? Okay, so then let's talk about what the solution means. So we found the solution for where the guppy and frog populations would be the same. How can we represent this solution? And what does the solution mean? How we can represent it is an ordered pair. We have an ordered pair, an input and output. And then I want you to tell me what this situation means in this situation. Should be something about the frogs, the guppies, and the pond. This situation. I want you to explain what your answer means. Okay. Finally, I want you to consider the functions f of x equals 2x minus 3 and g of x equals 2 to the x minus 3. What is the solution to the equation where f of x equals g of x? Okay, if you graph the two functions, we can see that the two functions intersect at two different points. So you see over here, we can see where they intersect right here and where they intersect right here. At 1, -1 and at 2, 1. So the solution to the equation, where we set the two parts equal to each other, are x equals 1 and x equals 2. Okay, and we can write that as x equals, and you see the brackets, 2, 1, 2. Remember that we're looking for the x values where they're equal. Okay? Okay, so finally you have an exit ticket. Use a table to approximate the solution to this system of equations, and then use Desmos to find the exact solution. So first you're going to make a table to approximate the solution, and then you're going to use Desmos to find the exact solution. If you have any questions, see me in class. I will talk to you later.